In 2017-18, the Nuffield Trust reported that the expected time spent in A&E was 173 minutes. So let's begin by defining a random variable x to represent the time spent by an individual within A&E. Now we're told that the variance of x is 900. And we can define the expected value of x as being equal to 173. Now we've collected 50 observations and calculated a sample mean of those 50 observations, which are randomly chosen and assumed to be IID, of 190 minutes. Now let's suppose that actually the expected value of x was 173 minutes. Now if there's been no change to the average time spent within A&E, then the expected value of x, the average time spent in A&E, would be 173 minutes. Also the variance will be 900 minutes as well. Now if the observations are IID, then we know that the expected value of the sample mean will be equal to the expected value of x. So in other words, the expected value of the sample mean will be 173 minutes, and the variance of the sample mean, if the observations are IID, is just the variance of the underlying random variable divided by the number of observations, which is going to be equal to 900 divided by 50, which gives us a variance of the sample mean equal to 18. Now the central limit theorem tells us that provided our sample is sufficiently large, and that means more than about 30, then any sample mean is going to be approximately normally distributed. So in this case we can define the sample mean as being normally distributed because we've got 50 observations with expected value 173 and variance 18. So our sample mean is going to be following this bell-shaped distribution centered on 173 with a variance equal to 18. Our sample mean has been constructed based on data from 2018-19, and we wish to test whether in 2018-19 the expected value of time spent in A&E has changed. So in other words, is the expected value 173? That's our null hypothesis, and our alternative is that the expected value is no longer equal to 173 minutes. Now in order to analyse this, we need to standardise our test statistic. So in order to standardise our test statistic to a normally distributed with expected value 0 and variance 1, we take the sample mean, we subtract the expected value of that sample mean, conditioning that the null hypothesis is true, and we divide through by the standard error of the sample mean, which is just the square root of the variance of the sample mean. And this Z statistic will follow normal distribution with expectation 0 and variance 1, which will look something like this. Now remember, at the 5% significance level, the critical values are plus or minus 1.96. So if the test statistic lies within that shaded area, we would reject the null hypothesis. So we have got our sample mean is 190, and we need to standardize this by subtracting the expected value of x bar if the null hypothesis is true, which is equivalent to subtracting the hypothesized value. So we take 190 minus 173, divide it through by the standard error of the sample mean, which is just the square root of 18, which gives us a Z statistic equal to 4.00. Now let's mark that on our diagram. And we can see that our Z statistic lies within the rejection region. Because it lies within the rejection region, that allows us to reject the null hypothesis that the expected value is 173 in favour of the alternative, which suggests that the amount of time spent in A&E has changed.